event. First off, on behalf of World Scientific Education and World Scientific Publishing, I'd like to thank our live audience for joining us today. And for the viewers who are watching the replay of this launch in the future, we're glad to see you as passionate as we are about empowering kids to grow their curiosity and knowledge. A few things to note before we kickstart the webinar. Number one, this event will include a Q&A segment where our panelists will attempt to answer your burning questions. So participation in this segment can be in the form of questions submitted in the chat, and please do submit them in the chat. You don't have to wait till the Q&A section to submit your question. So once you have a question in your mind, just type it in and we will read it during the Q&A session. Now, to keep the experience a pleasant one for everyone, please keep your microphones off throughout the event unless invited to raise a question. And please feel free to submit your questions. Yes, I've already mentioned that. Lastly, please note that this webinar is recorded and the recording will be shared publicly online after the event. So as mentioned at the beginning, we are launching the I'm a Math Star book series today, specifically set 1 of the series. If you don't already know, I'm a Math Star is a book series published by World Scientific under our children's program imprint, WS Education. The series comprises challenging math puzzles which are presented and solved step by step in story format. So step 1 in this series comprises of 3 books. Number 1, The Girl and the Birthday Problem. Number 2, The Boy and the Ants. Number 3, The Girl and the Princess. Readers are shown how to solve each book's intriguing puzzles using various math heuristics and techniques that are also taught as part of Singapore's math curriculum. The series includes a guide to problem solving by Dr. Yeap Ban Har, who will also be speaking later on. But before I introduce your speakers, I'd like to invite our partners for this event to tell us a little bit more about themselves. First up, we have Andrew from Teacher Online to tell us more about themselves. Andrew, please.
Hey, thank you so much. Yeah, I just want to thank World Scientific for inviting us to co-partner in this event, and also thank you. And so happy to see Professor Tay and Dr. Yeap. I was in NIE like 18 years ago as a trainee, became a teacher and then sports science, and became a vice principal for 2 schools before I came out to start Teacher Online in Singapore. So we are now have students from 21 countries learning Singapore mathematics, Singapore science, Singapore English, and as well as Mandarin. So very quickly, we have lessons, online lessons only. We started before the pandemic. So we run like online international Singapore school for students in Singapore and worldwide. So some of our classes, we have 5 nationalities. So it's really interesting, from Japan, Hong Kong, Indonesia, Malaysia, and Singapore studying together online. So it's amazing how online has, helped us reach the world to bring Singapore education overseas. So thank you so much, parents. I hope you can also enjoy and try our lessons. So these are some of the screenshots of our platform that we use for our online. We don't use Zoom, but cutting edge kind of technology that also will churn out students' report and stuff. Good stuff, like, whether student come in, the child come in late or leave early, and how much time he answers the questions and whatnot. Okay, now this is a special offer for our audience here, parents and students. We will be giving away quite a lot of lesson videos, and these videos are done by our head of mathematics, who has 20 years in MOE, and he was a chief examiner and also a PSLE supervisor for marking. So these are very good math videos of all kinds of topics, from primary 4 to primary 6. So if the kids around that age range, do sign up, scan, and later I'll put it on the chat. Okay, there will also be English and science videos. Very quickly, there's a science competition run by SMCC. My friend and partner as well, Henry, is here. He'll be sharing about SMCC. There's a vendor science international competition based on Singapore science syllabus. You'll be competing with students from around the world. It's happening in April. I think, Henry, you will share this. So thank you. Henry, all yours.
Okay, great. Thank you. So let me share my screen with all of you. So good afternoon, good evening, Prof. Yeap, Prof. Chan, Andrew, and World Scientific, and thank you for inviting us to join this exciting event to share with all of the math stars that are out there. So basically, SIMCC has been running academic competitions. We started with the Singapore and Asian Schools Math Olympiad in 2006. And in 2019, we were appointed by the University of New South Wales to take over the ICAS competitions in Singapore, Brunei, Hong Kong, and Macau. So today, we are running our competitions in 42 countries, and we are managing about 29 competitions in mathematics, science, digital technologies, computational thinking, including our latest product where we are launching the data science competition for students from Sec 3 all the way to university year 2 students. Okay. Today, we not only support students to take part in reputable and prestigious academic competitions, but also we run the International Junior Honor Society, where the top winners are invited to inducted into the Honor Society for free. We are working with Southern Illinois University to offer full scholarships as well as unlimited number of international student tuition grants. So I work with Andrew in terms of promoting Singapore mathematics, science, and English. And then at the same time, we are helping students in our network in the ASEAN, China, and India region to prepare for the Singapore MOE scholarship selection test, as well as the Singapore entrance test for all the government schools. And we have got a lot of very exciting programs to ignite the imagination and capability of all the gifted and students who do well in our competitions, including motivating all the average kids to try to perform better to win more awards. And yeah, okay. So okay. So then the next slide. Can you see my next slide? Okay. So hang on. So the next slide is basically this weekend we are running a direct school admissions preparation, as well as ASEAN Singapore MOE scholarship selection preparation for students. And then finally, we have this coming Sunday we are inviting Professor Lee Ann Laffey from the University of Florida to basically train our B+ students on how to gain admission to top US universities at a fraction of the cost that they will have to pay organizations like Crimson and other university counselors. So do join us. So it's a free webinar this coming Sunday, 11 o'clock for students and at 2 o'clock for teachers to learn how they can guide their students to their dream of getting to a top university in the US. So with that, thank you, and I wish you all a very successful event and to have more math heroes emerge from this particular session. So thank you.
Thank you, Andrew and Henry. So we've now come to the seminar segment of our event, and our speakers will tell you a little bit more about how to coach your child on math heuristics, tips to get them to understand mathematics better, how to break down math concepts into simpler terms for your child, and how the books in I'm a Math Star series can help you out with this with your children. So our speakers for today are Dr. Tay Eng Guan and Dr. Yeap Ban Har. Our first speaker is Dr. Tay. He's an associate professor in NIE. He represents Dr. Boaz, which if you have bought our series, you will know is the name of the author that we put on the cover. Dr. Boaz is actually a group of educators and not an individual who love children, maths, and math problem solving. So they've been named as the author for a Math Star series. If I can invite Dr. Tay up to say a few words.
Okay. Hello, everybody. Thanks for coming and to help share things and talk about the books which we have just written. Let me share my screen. Okay, so I'm a Math Star. Now, according to the blurb in the advertisement for this talk, we are supposed to cover these points, which is how to coach your child on heuristics, what are the tips to get them to understand, and how to break it down to easier terms for them. And finally, how can the books from the I'm a Math Star series help parents? Since it takes us about a year to cover all this in NIE, and I've only got 15 minutes, I'll do the best I can. I think as a parent and as a teacher, I find this framework rather useful in dealing with, not dealing with, I mean in teaching my, talking with my kids. It's called the hands, head, and heart framework, 3H framework. The idea is co-authored by a group of us in NIE and published in the Educational Studies in Mathematics. Now over here you see it one triangle with head, heart, and hands. Head, heart, and hands. And inside each triangle is another head, heart, and hands. I feel that when we talk to our children, we guide them, we should consider all three aspects. Often when we try to teach our children, we are concentrating on the head. Do you know how to add? Do you know how to multiply? Do you know how to solve problems? Do you understand heuristics? It's the head all the time. I think the way to the head is through the heart, and the way to the heart is through the stomach, but that's another story, okay? So how do we get to the head is we have to get our children liking maths, and sometimes even liking to talk to us, because if they don't want to talk to us, how can we even convey our teaching to them? But the heart is important, the head is important, and the hands ultimately. If you have the knowledge, but you can't do the problems. You think you understand, but you can't do it. You can't apply the things that you learn. That's a problem as well. So head, heart, hands. And then inside here, we have to ask ourselves another layer of question. That is, as a parent, do you have the heart to teach your child's heart? Because some parents are so, they say, I can't teach my child. I can't do it. I'm too very impatient. But we need to have a heart to teach the heart. We also need to have a head to understand how to reach the child's heart, and so on. For each of these aspects, we have a layer inside again. And that is the framework with which I interact with my children, and also I hope to get my trainee teachers. And also within the book that we've written, there is the aspects of the head, heart, and hands. In 2006, Carol Dweck highlighted the concepts of growth mindset and fixed mindset in the book Mindset, The New Psychology of Success. Fixed mindset means that people think that either they're good in maths or they're not good in maths. They're good in this or they're not good in this. Growth mindset says that yes, I may start at a disadvantage, but I can grow. Anybody can learn. So the important thing about the heart aspect of the framework is when we teach our children, we must tell them everyone can do maths. And it's true. Some people start off with a supreme advantage. They catch the math concept so fast, so quick. It's okay. It's like the rabbit going fast. And if it continues to go fast, the tortoise will never overtake it. But the tortoise can overtake the rabbit if the rabbit slows down and if the tortoise just carries on growing. That is something I believe in as well. So everyone can do maths. And so I wrote some books for children in primary school. And you can see that the problems are actually very difficult problems. And yet I think, and we've tested it out on children, and they can understand, they can read those stories. Now, these are my own children, so yeah, I love my children. So there's my son, and this is my daughter. But they've all grown up now. So now it's my daughter. And as you can see, we love to read. And so mother and daughter are reading on the bed. But typically when we read books, there's no maths book to read. It's always English books, story books, and so on. Mathematics is something that people very seldom think that they could read. This is another thing about the book. The idea of the book is that can we write the book, which is something like the storybooks that any child will just want to grab and want to read and lie down in bed to talk about with the parents. That's what we intend to do. And that's what we set out to do, and we wrote those books like that. So I talked about a framework for interacting with our children and making maths interesting. And within this framework is the matter of the heart, the head, and the hands. One way to interact well with your children is perhaps play some games. For example, I would play with my children a game like, say, 4 fours. What's 4 fours? Okay, you have 4 fours. And ask, can you make the number 1 with 4 fours? You can use plus, times, divide, and what else is there? Subtract. Okay. Can you? I think it's easy, right? So you have 4 plus 4 bracket divided by 4 plus 4 bracket. That will give you 1. How about 2? You can have 4 times 4 bracket divided by 4 plus 4. That's 16 over 8. That's 2. How about 3? You can have 4 plus 4 plus 4 bracket divided by 4. That's 3. And so on. So it's something for children to be able to do some mental arithmetic, make them more familiar with the numbers, make them more familiar with the operations. Another game I play with, even till today, because 4 fours are quite limited, is make 24. It's a game that I won't use with my undergraduate students, my postgraduate students, and teachers in school. Make 24. So the game is very simple. You make 24 given 4 digits, for example, 1, 2, 3, 4, and using the 4 operations, plus, minus, times, divide, can you make the number 24? So here we go. We got 1, 2, 3, 4. How about 1 times 2 times 3 times 4? Is that 24? Unfortunately, this is not a classroom, so I can't get direct response. But 1 times 2 times 3 times 4 would do the job, yeah? Okay, maybe I should write it down here. Okay, so 1 times 2 times 3 times 4. Yeah, that should be 24, yes? Is that the only way? Let me see. How about how about 1 plus 2 plus 3? That'll give us 6, and then times 4. That will also give us 24. Yeah. Now I have a number of cars through the years. One car is license plate 2142. 2142. How do I make 24 from 2142? Let's give you half a minute to see whether you could do 2142 and make 24. Now, 24 is an interesting number. 24 can be written as 6 times 4. And it can also be written as 12 times 2. It can also be written as 8 times 3. Now, one of the things in the blurb was, can I bring across the idea of heuristics and how to teach children heuristics? What are heuristics? Heuristics are strategies in mathematics to solve problems. They are not formulas. Many people associate mathematics with formulas, but within mathematics, the exploration stage of mathematics, we use heuristics. Now, one of the heuristics is called sub-goals. So if we have a sub-goal, for example, now I'm trying to make 24 with 2142, and I know that 24 is 6 times 4. So if I pull out this 4 from here, I'm left with 212. Now, can I make 6 from 212? Oh, yes, I can, because it's just 2 plus 1 times 2. That's 6, right? So if I 2 plus 1 times 2, and then I multiply by 4, that will give me 24. Am I right? Now, the purpose of this is that the child doesn't just simply try all possibilities and get very tired. He will learn the heuristic called, when you solve a problem, sometimes you go for the sub-goal. So since I already have 4 here, my sub-goal is just, can I make 6 from 212? And it turns out Yes, I can, because I have only 3 digits to play with. And my mind is more relaxed. So this is an idea of how in games we are able to talk about heuristics to our children and say that, oh, you know, too many numbers. So we just concentrate on some sub goals. We already got 4, let's try to get 6. Or maybe we already have 3, we try to get 8. Okay, so for example, 4284, I have another car, which is, oh, sorry, this is my motorbike and this is my car. So 4284, 4284, I already have 8 down here, right? So can I get a 3 from here? Can I get a 3? How do we get 3? Not so easy to get 3, right? So never mind. I will do 4 plus 4 here. That will give me 8. And 8 times 2 will give me 2 8s. So 2 8s and 3 8s, that will give me 24, right? So it'll be 4 plus 4 plus 8 times 2. You see? This is an idea of sub-goals. I move on. So you can do things by investigation. And one thing about teaching children is that, for example, we have subtraction. And subtraction is ungrouping by acting it out. You know, 24 minus 7, how do you do that? So we usually tell the child, 24 take away 7 is you bring over 1 here, and then 14 take away 7, right? Or 24, yeah. So that will give us 7, 1. And then some children can't get it. So what we do is, we probably have some tools like this, you know. And we say this is 24, 10, and we have 4 here. And we ask the child to physically give us 7. Now, he gives us 1, 2, 3, 4 here. And he has no choice but to take out the rubber band to give us the other 3. So when the physical action happens, it is in some sense, in some papers, they write called embodiment of action. When you embody the action, you can remember that the 24 take away 7, you have to move 1/10 over to the 14. I'm looking at my time. Time passes. Right, let's go to the next one. If you talk about heuristic, then we have to talk about Polya's problem-solving strategy, which is mentioned at the end of the book that we have. So I will not go through it. It consists of 4 parts: understand the problem, devise a plan, check and expand. While working with a child, you're dealing with a problem. One way is to solve the problem while modeling the technique for your child. And then you ask the child to work out the same problem, him or herself. And then you pose a new problem to ask your child to solve the new problem. And then you ask your child to pose a new problem, him or herself, and ask your child to solve the new problem. This is a way in which the interaction with the child is more than just for exams. It is to strengthen the understanding of the child. And most important of all, as Confucius says, I hear and I forget, I see and I remember, I do and understand. This is where the hands and the head get together. So reading mathematics, there they are. I'm reading books, not mathematics. And we have these books that we have down here. In these books, we attempt to put in the hands, head, and heart framework. How do we do that? In a book, there is a story. Typically, these problems come from things that we will read in maybe newspaper columns, and people give you a problem, you know, and it's very short, maybe just 1 paragraph. So if you're interested, you do it. People like me are interested. Most people are not interested. But we put it in a story. So in the story, we reach to the heart of the child as he reads the story. And in that story, there's always a struggle. There's the human part of the story. Mathematics is about struggle. It's not like people like maybe say, oh, you're a professor, you should easily solve the problem. Oh, we struggle in math. That's why I don't have much hair to live this life, you know. We struggle. And in that story, there's the struggle. And yet there is a solution. And that's where the head comes in, the solution. And at the end of the solution, we have the solidifying. That is, we give new problems in which you will strengthen what you've already learned. That's how these stories are set. Okay, now let me just give you an idea of what the story looks like. So I shall. Okay, wow, there be poor, very good. Now, let me see. I'm supposed to share one more thing with you, and that's the story, the book itself. Okay, look, let's have a look at that book here. So here is the girl in the birthday problem. Sorry. It was the first day of school. School was fun. The girl was excited. Her classmates were fun to learn with. Now, all these are original drawings by Chang Yit-Hua. Her teacher, Miss Cheryl, was very interested. All too soon, it was time to go home. Daddy and Mommy came to fetch her. Miss Cheryl and Mr. Dowd, the principal, waited with the girl and greeted her parents. Your little girl told me that you love puzzles, said Miss Cheryl cheekily. Would you like one now? Certainly, Mommy said with a twinkle in her eye. Okay, I'm going to ask you to guess my birthday. With some hints, of course. Miss Cheryl wrote 10 dates on the whiteboard in the classroom. My birthday is one of these dates. Miss Cheryl took a piece of paper, wrote a word on it, gave it to Daddy. It's the actual month, Mr. Lee, she said cheerfully, and it's for your eyes only. Then she took another piece of paper, wrote a number on it, and gave it to Mommy. It's the actual day of the month, Mrs. Lee, she said blithely, and it's for your eyes only. The girl looked on with great interest. She waited to see what her parents would say. Daddy looked at the month on his piece of paper, and he looked at the 10 dates on the whiteboard. Then he said, I don't know when Miss Cheryl's birthday is, but I know that Mommy doesn't know either. The girl looked intently at Daddy. Why would he say the second part? She whispered to herself. Now, Mommy made some notes on her piece of paper and said triumphantly, I know Miss Cheryl's birthday now. The girl was surprised. But before she could ask how, Daddy pronounced, if Mommy knows Miss Cheryl's birthday, then I know it now too. The four adults laughed merrily. That is the problem. Can I guess Miss Cheryl's birthday as well? Certainly, dear. Can I see your paper? But you won't need either, my dear, Mommy smiled, if you had listened carefully to what we say. The girl was lost for words, and then the solution of the problem. We try to reach the heart of the child, and by reading together, we hope that even relationship with the parents can be improved because these things both can read together. So we've done it very successfully for English books. Let's try for maths books. Thank you.
Thank you, Dr. Teck. So now I'd like to introduce our second speaker, Dr. Yeap Ban Har. I understand some of our audience today used to study in NIE, so you know who Dr. Yeap is, but for everyone else, Dr. Yeap is one of the world's leading experts in professional development for teachers in Singapore mathematics. As an accomplished and inspirational speaker, Dr. Yeap has spent 10 years at NIE, where he taught a range of educational courses and was involved in several funded research programs in mathematical education. He continues to teach courses and supervise practicums at tertiary institutions around the world. He sits on the advisory board of several schools in Singapore and Asia, and was also a consultant for World Bank projects. Dr. Yeap, please.
Good evening, everyone. Thank you very much for joining us this evening to listen to us chat with you how, as an adult, a parent, we can help children, students, become better in mathematical problem solving. Guan has outlined quite a fair bit about heuristics and a range of things, including capturing the hearts of children. I suppose that's pretty important in the learning of anything, including mathematics. I will add on to what he has shared with you. In my brief chat with you, I would like to share with you perhaps a small list of things that will support students in using heuristics. To me, heuristics are somewhat like tools. And in order to be able to use tools well, we need to have certain abilities. Example, you give me a carving knife. If I do not have the skill to carve beautiful things out of a watermelon, I will not be able to produce that beautiful piece of art. I might just destroy the watermelon in the process. So the heuristic is the knife that I have in my hands. And unless I have certain skills to use the heuristic, to use the knife, I may not end up with the intended outcome. I would like to share with you in a short time, perhaps 5 major abilities that when students have, they would be able to handle a range of problems, including maybe somewhat challenging ones or those that are unusual. I have a problem just at the back of me. Maybe I move aside, you can see it better, right? So yeah, well, this could be a problem. Maybe in some competition. It could be a problem in a school examination. It's a figure, right? So all straight lines, closed figure. And given that the sum of the angles A and B is 95, as you can see, the angles A and B in the diagram, so the sum of those 2 angles is 95, we are asked to find the sum of 3 angles marked in blue, yeah, at the various corners of the figure, right? So something like that. I suppose if you know what the answer is, or if you know the way to solve it, because you have solved it before many times, then this task is probably not a problem to you. It would be an exercise, a mere exercise, because you have done many similar tasks prior to this. But if you are wondering, oh, what do I do? I have no idea where to begin. What can I do? I suppose then that might be a problem for us. Yeah. So I'm sure there are many ways to solve this problem. Some of you are probably trying to solve it now, yeah, to figure it out. So I would like to share with you some of the big abilities that when people have, they can use a range of heuristics rather productively and successfully. For this particular problem, I suppose visualization, meaning the ability of the mind to see beyond what our eyes can see, is quite important. The ability to visualize. For example, in this particular problem, there are some lines that our eyes cannot see yet, but our mind may be able to see it. And we may think of, oh, okay, I can do this, I can do that. Yeah. So some of us may be thinking, okay, the 2 angles given A and B, that's 95, and I can see a small triangle. So visualization includes the ability to erase away unnecessary lines. So visualization is being able to see what is not there, but also being able to unsee the noise in the diagram. So as we focus on the small triangle that contain A and B, our mind essentially erases all the unnecessary lines, the so-called noise. When children's mind is agile that way, being able to see what is not there, but important things, also being able to unsee or erase away lines that are there, but it's not necessary for us to look at it. And if we can remove it, that will bring out certain clarity. So sometimes some students may use highlighter, or they will draw lines over the diagram to highlight to themselves a particular part of the figure. So some of us may see the small triangle that contains A and B, and we kind of know, okay, if A and B is 95, that means I do know the third angle, because we know from primary 5 that the sum of interior angles in a triangle is 180 degrees. And then we also know from primary 5 about the vertically opposite angles. So if we know that angle, the third angle, I also know the vertically opposite angle. And from there, many of you can imagine how you might continue. A small hint could be, some of us may be thinking about adding an additional line to the figure to create a somewhat large triangle. That line is not there in the diagram, but our mind might be seeing it. All right. So parents, I'm not so much interested in doing this problem with you, but I know some of you are solving it. What I was talking with you about a while ago is visualization. So when children develop the ability to visualize, can see what is not there, can also not see what is there, being able to erase away the unnecessary information. Ability to visualize, the mind's ability to see beyond what the eyes can see. As teachers, as adults, we can help children develop ability in visualization in various ways. One of the ways, I suppose, is extensive use of concrete materials in the early stages of learning. So when we manipulate objects, our brain, our mind concurrently develop. And that particular ability that we develop when we are active is the ability to visualize. Another way to develop visualization ability is through the use of scaffolding question. The way I did it with you, I said something like, oh, can you see a triangle that contains angle A and B? Or I might say, oh, maybe I can add an additional line to create a large triangle. So what I was doing with you a while ago is to give us some scaffolds. Could be in the form of a question, could be in the form of a hint, scaffolding. So by asking scaffolding questions and by letting students be active in the learning process, hands-on materials, those are at least two ways visualization ability can develop. Other than visualization ability, what else is important for us to possess in order to be able to use heuristics well? Something that Guan has alluded to is ability to see patterns. The ability to see patterns and hopefully at some point generalize the pattern, and we may even get conjectures, and if we have enough technical skills, we may even be able to prove the conjectures. But it all begins with being observant. It all begins with being able to see a pattern and then generalize whatever that we manage to observe. So visualization and ability to see patterns, those are what I might call big abilities that when people have, when students have, that will give them, that will put them in a better position to use heuristics in productive ways. So I promise you a small list. I've articulated two of them: visualization, being able to see patterns. I invite you to think, what are some of the ways we can do as adults to help our children develop those abilities? I have given you two suggestions how visualization can develop amongst children by letting them be active, by letting them use concrete materials, also by asking scaffolding questions the way I was demonstrating it. I wonder what we can do as adults to help our children become good at observing patterns. As Guan mentioned already, the ability to do mathematics is negligibly genetic. and predominantly opportunity. You might remember Guan saying that everyone can do maths, right? Every child can do maths. It's not as if some people are gifted with that ability. I'm not talking about savants, but regular people like you and I, depending on the opportunities we have, we might either become quite good at it or, develop some negative, unproductive mindsets against it. And if we provide ample opportunities for our children to become good in a few things, those few things can guide them when they are executing using heuristics to solve novel problems, meaning problems that are not familiar to them, or somewhat complex and challenging problems, such as those in competitions or one or two of the more difficult problems in their school examination. I have mentioned two such abilities. Do you remember them? Visualization, as well as ability to see patterns. What are the rest? Another one that you have heard Guan mention is number sense. He did not use that phrase, but he was talking about number sense when he was inviting you to make correct expressions using the digits in his number plates of his cars and motorcycles, right? Trying to make 24 using 4 single-digit numbers. So you probably would remember he mentioned that it's not just trying every possibility. It is having some sense of numbers, having that sense that certain numbers go together to give you another number that might be useful in producing 24. So when they see that string of 4 numbers, they would have the number sense to say that, well, if I use these two, I can generate a number that is going to be helpful, useful in producing a value of 24. Number sense. What are some good ways to help children develop number sense? Number bonds. When students do number bonds, what they are doing is to playfully break numbers up in different ways. For example, 51. 51, I can do 51 as 50 and 1, but I suppose 30 and 21 is also possible. Well, 11 and 40 is also 51. And when presented with a task, let's say simple long division, 51 divided by 3. A child with strong number sense might think, well, 50 and 1 is probably not suitable because 50 divided by 3, that's rather inconvenient. But 30 will be quite good, isn't it? 30 divided by 3 is quite easy to do. So I might want to see 51 as 30 and 21. 30 divided by 3, that's easy. That's 10. And 21 divided by 3, I suppose that gives me 7. 10 and 7, that gives me 17. So 51 divided by 3, that's 17. So when a child is good at number bonds, they would be able to do a range of things, such as calculation quite easily, or something more complex like the investigative problems that Guan was sharing with you, whether it was the 4-4 task or the make 24 problem. Number sense. So number sense can be developed when children are flexible in how they break numbers apart. That flexibility in breaking numbers apart in a school system is called number bonds. And they have been taught how to do number bonds from kindergarten actually, but officially in primary 1. But they do it like in primary 3, the long division task I just given you, they likewise do number bonds. Yeah, so number sense can be developed by the use of number bonds. Another way to develop number sense, I suppose, is extensive use of mental calculation. So when we do mental calculation the way I did a while ago, so when I was dividing 51 by 3, I did not write it down. I was just playing around with it, thinking of 51. The way I was doing it, that's mental calculation. Children who do more mental calculation, they tend to be stronger in number sense. So other than visualization, ability to see patterns, number sense, what else would be counted as a big ability? Metacognition. Metacognition is just a big word educators use to describe the brain's ability to manage itself. So it's the manager of the brain. Our brain have workers like in a factory, but they also need a manager to manage the workers. So they are able to monitor whatever that's happening. When you do something that is single step, most likely you do not need very much metacognition because it's a single step. You carry it out and then you are done. But in a multi-step situation, of which challenging problems would be, we have to manage quite a few steps in our thoughts. And many students are unsuccessful in solving challenging problems because they do not have a well-developed metacognitive ability. And again, I want to emphasize, all the abilities I have mentioned, thankfully, they are developed because of opportunities given to children. These are not gifts that you are either born with it or you will never be able to acquire it. So it is a series of abilities that one can develop throughout one's life. So thankfully, which means everyone, given the right opportunities, can develop those abilities and hence be successful in solving, challenging problems in exam. But I suppose it's more important than just that. When you are able to monitor your thinking, you can imagine what else you should be able to do. Likewise, if you can visualize, it's not just mathematics that require visualization. In science, some things are so small, like atoms, and some things do not exist in a physical manifestation, like energy, or in economics, theory of demand and supply is something abstract. And unless a person have the ability to imagine, to visualize when they are studying all these things in secondary school or JC or beyond, they would struggle somewhat. Visualization, ability to see a pattern, number sense, and what's the fourth one? Metacognition. The final one is the obvious one, communication. Students obviously need to be able to understand when someone says something to them. When someone says, given the sum of the angles A and B is 95 degrees, they need to be able to understand what has just been told to them. When they are given a diagram, they need to be able to comprehend the diagram. So that's part and parcel of communication, being able to understand someone when someone tells us something, whether using words, orally or in written form, the verbal language, or the visual language, pictures, or in this case, diagrams, as well as sometimes in notation and symbols. So communication, ability to understand someone, but also the ability to make other people understand us. So I should be able to present my ideas orally or in written form, like when students are showing their working. That is part of communication. So those are the 5 big abilities that students should have. I hope you remember the 5. Other than communication, what are the other 4? All right. Thank you very much.
Thank you, Dr. Yeap. We have now arrived at our Q&A segment. So to start things off, let me start with a question that was posed before the event. Dr. Yeap, you described math heuristics earlier as tools that need the right skills to be used properly. So if we as adults don't have the skills, is there a way we can learn them, or do we not need to learn them before we teach kids how to use them?
I would say 2 answers. Obviously, it's better if we know something about it, right? And then we can act as the guide. So for those of us who know it quite well, we are almost like the mentor. We are guiding them, we are coaching them. But let's say I am a parent and I know very little about what I am guiding my child with. Let's say my child is studying economics and I know very little about economics because I never studied it before. I can still help my child. I can help my child as a sounding board. I can help my child as almost like a cheerleader. I can help my child as in, I can ask, oh, by the way, never mind. The problem is quite difficult. Never mind. Let's do it together. Let's read the problem together. So in the first model, I know a lot. So I solve the problem for the child. And then from that experience, I guide my child to hopefully go through the same path of success. In a second model, when I don't know very much, I am solving the problem with my child. I am solving the problem with my child, and my child can benefit from my wisdom, hopefully, my wisdom as an adult. Even though I do not know very much about the content, but having lived life a bit more than the child, I can use my wisdom to model for the child to see what I can do when I do not know how to solve the problem. So yeah, it is good if we know how to do it, if we know quite a bit about heuristics. And thankfully, heuristic is not rocket science. Most people, most adults, if we just spend a bit of time watching some videos and going through their school books, we probably would have some expertise in it. But even if we don't, the model of solving a problem with a child, it's actually quite useful. Thank you.
Thanks, Dr. Yeap. So you mentioned just now solving the problem with a child. So we have a question from our shy participant. The participant asked, you mentioned 5 big methods to solve math problems. I won't give the answer, so whoever needs to know, please watch back the video later. So the participant asked, how do I help my child think, decide, and implement the best heuristic when he faces a tough question?
How do I help my child? Typical ways of adults helping children. Yeah, as an adult helping children.
How to help them choose the best heuristic for the question.
Yes. Yeah. How to help them to do anything actually. So my answer is for anything, but in this case you ask how to help them choose the best method, the best heuristics, right? One way is by modeling. So when you solve the problem, you are thinking aloud. You are modeling for the child to see how you as a successful problem solver or expert problem solver go about choosing your heuristic. So the first answer is by being a model. But you do not want to be doing that all the time. At some point, you also want to be the scaffold. So I was demonstrating scaffolding. So you might be asking the child questions. Oh, I think we might have a chance at using one of these 2 heuristics. So the child might be lost totally, and you give them a hint. Maybe we can make a list. Maybe, I'm not sure whether it works. Or maybe we might draw a model. I'm not sure which one. Why don't you try? So I was giving them a hint. One of those might work, or both might work, depending on the child. And I was being a scaffold. So being a model, being a scaffold. The last way is letting go. At some point, we must let go to let a child have a go at it. Meaning, when a child says, oh, I'm not sure what to do, which heuristic to choose, instead of saying anything helpful, you might just say, okay, why don't you give it a go? After 5 minutes, then we'll have a chat again. So sometimes that space and time just to have a go at the problem that the child initially thought they cannot do, but just spending a couple of minutes, they might say, oh, suddenly they realize, oh, actually, I know which heuristics to use. So how do I help my child to choose the right heuristic? Number 1, by being a model. Number 2, by providing a scaffold. And number 3, by letting go, right? Those are the 3 common strategies many teachers use in helping students learn to choose strategies. Thank you.
Thank you, Dr. Yeap. Now we have a question for Dr. Tay, because just now, Dr. Tay, you talk about getting to the heart of students. So Lynette asked, what are some good ways to get to the heart of students? Dr. Tay, you're currently muted.
I think I did reply over here. Let me see, what did I say? Heart of the child. Okay, I said that the child must trust you and your intentions. With my children, they know I gave my children the 4-4 question, etc. And my son, I show you 2 children. My son is much faster than my daughter. And he didn't like it. He thought I was testing him and so on. So I backed off. And then sometimes when he asks me questions, I will go the long way, which is to explain the process and so on. Sometimes he just wants the answer. But over time, the children learn to trust you and your intentions. I'm not doing this because you're my son and it's very embarrassing if you do badly. So I'm doing this because I think it's the best thing for you. But if you don't trust me, I will back off a bit. And after a while, when you reach the heart of the child, trust is there. And then you see that everything I do, I'm doing my best for you. I try to make it interesting for you. And if the math looks horrible, I can't help it. And with regard to my daughter, she was doing badly at P4. I realized because I left her alone for 4 years. And at P4, she was doing badly. So, okay, roll up the sleeves. You must memorize your multiplication table, because that's the one. If you don't memorize, you have to work it out. It's too late when you do long division. So she has to trust me. And that was the most painful part of the maths education for her. But once she got the maths, like Ban Har was saying, the number sense there, the fitting of the numbers, everything else clicks. And that year she got a good progress award. So heart of the child, trust, and then try to make things interesting. And sometimes you have to have tough love.
Thank you, Dr. Tay. So we are nearing the end of our program, so I will just ask one more question. This question comes from Ryan Wu. He asks, when using the CPA approach, how do we determine the sweet spot that the child is ready to move to the next stage? And what are some key indicators you look out for?
And Guan, you want to take this?
Right.
All right, I suppose we'll give the same answer anyway. The CPA approach, for those less familiar, C for concrete. So children begin learning using concrete materials, like learning fraction. They fold paper to get equal parts, and they can cut the parts out to check that they're equal. P for pictorial, hence visualization. A for abstract. So the CPA approach basically talks about how students get to the eventual abstraction, because mathematics is inherently abstract. And in order to get to the eventual abstraction, the bridges that they go through would be the concrete and the pictorial representation. The concrete pictorial abstract progression is not a linear one. It's not as if one day we do concrete and then bye-bye, tomorrow we draw pictures. And then after that, we just do symbols henceforth. It's not like that. It is a to and fro process. It is that that path that children go through, right? So they know, okay, I can do concrete and then I can draw pictures. Now I can solve it abstractly. But sometimes when the problems get too difficult, I might revert back to drawing and sketching. But when it is quite easy for me, I just do the calculation, the abstraction. But when it gets hard again, I don't know what to do with the calculation. I might now begin to doodle and sketch and draw. And if necessary, sometimes I may pull out paper to fold and try to see, right? So it is not really like a stage that you go through and you leave behind entirely. It is, if you like, it's a bit heuristic in nature as well. It is a rule of thumb that, okay, when things get too hard, I just draw. In fact, when it's too hard, I try to act it out. And then the acting out give me some insights. Maybe I can do the calculation now. Or the drawing and doodling give me some enlightened thoughts. Now I can do the calculation. All right. So the question is, how do I know the child is ready to move on? It is more important for the child themselves to know that they are ready to move on. So what our role as an adult is really is to guide the child in having that metacognitive realization. So often I would ask the child, whenever they solve a problem, I always have two questions I ask of them. Can we draw? So after they read one sentence or two sentences in a word problem, for example, I would often ask the question, can we draw? If we can draw, we draw. Can we calculate? If we can calculate, we calculate. So that is to help the child understand that, okay, if I can calculate, I just go ahead and write down the equation and the number sentence and calculate it. But if I cannot calculate, either because I don't see the right operation to use or because I don't have enough information, I might then start with a drawing. Yeah. So I suppose I'm not answering your question directly because it is not so important for us to know that, well, the child is done enough with concrete. It is not like that. So it is more important to look at how a child is comfortable in moving to and fro that pictorial abstract progression, or sometimes may even go all the way back to using the heuristic of acting it out. All right, thank you.
Thank you so much, Dr. Yeap. So we are out of time for tonight, and we're sorry we could not answer all the other questions tonight, but maybe we will see if we can get it answered on our social media pages. So a recording of tonight's webinar will be uploaded onto World Scientific's Facebook and YouTube. The links will be sent to all participants in an email tomorrow. So thank you all for joining us today. Once again, I'd like to remind our viewers that set 1 of I'm a Math Star is available for purchase at World Scientific's website. And you can get when you get to the order page, you can get a 20% discount by using the promo code WSEMath20 at checkout. This offer is only valid till 13th March, so you only have 3 days. So place your order ASAP to not miss out. Thank you, everyone. Goodbye and a good evening.